This is an interview with Carlyle Ashley conducted for the ASHRE Historical Committee for the Leadership Recalled program by Bernard Nagengast on June 28, 1988. Regarding Carrier's unit conditioner.
Carrier decided to go into the manufacture of relatively small equipment and to build up a line of equipment that would eventually be handled by dealers and distributors. And I was just married at 1926, and shortly after that, J.I. Lyle called me in and told me that they wanted to design a unit air conditioner. This was not a room air conditioner. It was a unit air conditioner.
Which was to be used for commercial purposes, like stores?
Yes, largely for small stores and places of that sort, more than anything else. Some small manufacturing, and the capacity of that was 2,500 CFM. That was the first one that we built. Later, we built a little larger one. And I was given the job of doing that. And I was imbued at that time, and ever since really, with the idea that you ought to economize as far as you could on the use of energy. And I always have felt that way. And so what I designed was called the Ejected unit. And it had a very interesting, it was about 2 feet square and vertical, about 7 feet high, I guess, or a little over 6 anyway. And fan in the top with a motor drive. And then directly below the fan, I carried an extension shaft. And I had a fairly good sized thing, I think it was around 3 inches maybe, that went directly down as an element that went right into the water at the bottom of it. This was a spray unit. It was not a coil unit at all. As a matter of fact, at that time, particularly in Carrier, I think, but maybe in some others too, we regarded spray as being the thing rather than, as a matter of fact, we didn't have much in the way of coils other than just bare surface, except for airfin, and that was a very new thing at that time. And so the thing that I designed had an element that was about 1.25 inches maybe, or something that sort in diameter at the bottom, and then tapered up to about 3 inches. And when you rotated that, it would pick up water from the bottom and deliver it up to the top. And up at the top, I had a series of spray nozzles mounted on arms and pointing backwards. And the spray nozzles, as I remember it, handled water at about 40 pounds pressure. And the whole thing rotated, and the spray, while it was delivered at a very high velocity, actually wasn't very high when you consider the rotation. So it produced a rather intense spray. And the result was that you got a nice spray in there at a very high efficiency relative to most of the spray. It was about, I think, I don't remember whether it was, let's say it was around 50%. It might have been a little less or a little more. About 50% of the energy of that, we had no pump on it at all. This was the whole thing, you see. And we sold a fair number of those. They were designed to be stamped out, and they worked quite well. The main problem, and I guess I was a little young to realize that initially. Well, I knew that we had a problem, but I didn't really get a complete solution for the problem. And that was that you had a bearing, of course, in the bottom here. We used lignum vitae initially.
What was that you used?
Lignum vitae.
What's that?
That's it's a wood that is a very dense wood and was used in many situations as underwater for lubricants, for bearings. But we really had a bearing problem on the thing, and so eventually we did get away from that design. But it really went very well, and it did introduce the company to the small operator, the small dealer. Prior to that, most of the jobs were large jobs. I remember going down to a candy factory in Pennsylvania somewhere, and one of the problems that we had here is that you had a long room and we had to distribute the air for that. And then I realized also that we had an air distribution problem as well as the problem of the unit itself. And so over the next few years, I made a rather detailed study of how to distribute air. And at that time, we had, I don't remember what they called the outlet. Essentially, what it was a thing that most of the ducts that you had those days were bare ducts, rectangular. And this thing sat on the sides of it, and it had about 2 or 3 louvers or fins on the inside of it to redirect the air at right angles to the duct.
Almost like scoops in the airstream.
Yeah, well, it wasn't a scoop. It didn't go into the airstream,
okay.
But it was built on the outside of the stream. And but it had on the outside had places where the air didn't come out at all. I remember that there were blank spaces, and then the air came out in 2 or 3 places. And one of the interesting projects that I worked on that, I developed the idea that if I could just let the air come into the top and bottom of these little places in between the slots where the air came out, I could get better distribution than I could with the outlet itself. And so I built up an elaborate system of testing and so forth. And the testing, the way you tested it was very interesting. If you heat or cool the air and then deliver the air to the room, you can tell what the mixture of room air and air from the outlet is simply by measuring the temperature, which is a very simple way, of course, but it's very good too. And so I ran a series of tests on it, and then I tried it without any of these additions that I put on. The results were exactly the same.
Which surprised you, huh?
Well, a little bit, yes. But I realized that, well, I realized that I began learning about airflow and distribution and so forth. And I realized that the air was being sucked in. That is, you had the jets here, and they had a sort of a V envelope as they went out. They finally merged together, but in the space between those, the air would come in between them anyway. So you really didn't need to have a guide for it, because the air came in any case. And so that was one of the early lessons.
Back when you were talking about the unit conditioner, then how long was that manufactured before it was discontinued?
Well,
and when was it first put on the market, actually?
I would say that I think it was put on the market either in 1927 or maybe 1928. I'm not sure. I'd guess 1927, maybe late 1927. And it was sold, I don't remember, of course, shortly after that you had the Depression, and it was sold into the Depression, I'd say. And then everything collapsed pretty much.
And that was sold by the so-called Standard Products Division, or is that something different?
Yes, I think that was it. At a slightly later date, and this was around 1929 or 30, Carrier started to organize a dealership and distributorship to go along with it. I think they organized the distributorship first, and then the distributors got the dealers. And there were many distributors in 1950, 1960 who were the same people that had been gotten originally. There was a very able organizer and salesperson that developed that organization, and it was one of the big money makers for Carrier, because you had the Standard Products Division, and then you had the special designs that were handled by the Carrier engineers directly. Carrier started out as an engineering contracting company, and they didn't have anything to offer. They bought practically everything outside. Maybe I ought to go back at the beginning of the questions you have.
Okay, yeah, we can start out that way. And I guess the first question was when you were growing up,
yeah.
were you interested in mechanical things?
Yes, very much so. Well, I thought I had your things here, but I don't seem to find them.
Yeah, if you want another copy.
Yeah. I don't know what happened to it. Well, that's all right. I can use your other copy here. Yeah, and I had all kinds of ideas. When I was between 6 and 10, for instance. And There's an interesting thing that I might make an observation on that happened years after that. When I was, I'd say it was around 1950, we got interested in trying to look for somebody who was creative and try to find the people who were creative, as distinguished from maybe highly intelligent, but not particularly creative. And we got a psychologist, an industrial psychologist from Syracuse University, because at that time we were at Syracuse. And he rummaged through his various tests and finally selected some that he thought might bear on the problem. And we gave it to some of our employees. And then at the same time, we rated the employees on the basis of productivity, on the basis of creativity. And we tried several different tests and tried to determine what it would be. Well, the results were completely negative. I mean, they were, I shouldn't say negative, they were neutral. I mean, we got no indication from the tests of anybody in the organization that could correlate with creativity. And in thinking later of of how do you recognize somebody who's creative, I think there's a very simple answer. You ask him or her what they did between the time they were 6 and 10, between the time they were 10 and 16, what their activities were, what kind of interest they had. And that will separate them out, because you'll find out that the people who are creative later were creative as children.
And so that brings us back to you. Were you interested in mechanical
Oh, yes,
things when you were
very
young?
much. Yes. And I'll tell you something that you might find of interest. My mother and aunt and uncle grew up in the town of Angola, which was west of Buffalo by about 30 miles, 20-some to 30. And Willis Carrier, Mr. Carrier's father, grew up in the same town. And Willis was somewhat younger than my mother and considerably younger than my aunt and uncle. But they were very good friends. And so it was quite natural. We lived in Washington when I was growing up. And it was quite natural that when he came down to Washington for visiting, that he should visit us. And he looked at the things that I'd been working on. And he told my mother and father, he said, don't allow him to stop being creative. And he said, be careful to be sure that this creative talent is not lost. And I'm sure that he thought back to the time when he was a boy too. And my grandmother was a boy that encouraged him greatly to go to Cornell. He was very poor. His father was a farmer, and it was in a bad time of the generation, of the century. But at any event, she recognized his talents, and when he finished the academy, the equivalent of the high school there, he started teaching for a while. But she encouraged him to go on and get a college degree, and he didn't have any money. But he went to live with my uncle in Buffalo, who was a veterinarian. And he went to high school there and got extra training that allowed him to take the high school, state high school examinations that qualified him for a tuition scholarship. And then he went early to Cornell and took a cram course on things that might be asked in connection with a cash scholarship, and won that too. So he had a tuition scholarship and a cash scholarship, and then he did work. I think he waited on tables to some extent, and later he worked with a new organization that provided laundry service to the students, and that service, incidentally, is still continuing at Cornell. It's grown considerably in size and so forth, but then they do other things too. But he was not necessarily a founder, but he was one of the first people in that organization. And so he finished his college organization and then went to Buffalo Forge Company directly from Cornell. And one of the interesting things about that is that within a year after, well within a year after he had gone with Buffalo Forge, he persuaded the management to let him design and build a test laboratory where they would run tests on the equipment. The trouble with the Buffalo Forge Company is they had no information on what the performance of their equipment was. It's unbelievable that was the case. And so he started out with that. And within 3 years, or maybe 4, no, I think it would been about 3 years, he got the basic concepts of air conditioning. But so this is almost unbelievable in relation to what you get today. And yet, if you look at a lot of new things that are being in the process of development, there are a lot of things that are worked out, developed in people's garages.
That's true.
And so really, on the forefront of your development, it's not an unusual thing to find that kind of thing that are done by high school or college kids or people of that sort. And I dare say that every one of these people you'll find is a highly creative person.
Well, one thing that you just told me I thought that was interesting is that I didn't know, and that's that your family then played a part in the fact that Willis Carrier decided to do it.
That's
that
right.
He became an engineer because of the encouragement from your grandmother.
That's right. He certainly did.
That's amazing.
Mm-hmm.
Well, coming back to you again, I take it then that you would characterize yourself in the area of the creative person because of what you did as a child.
Definitely. I still find, as a matter of fact, that I think in a different way than most people do. And I find it a little hard sometimes to adjust. And I find it hard to explain too, because I'm fundamentally a problem solver. I know how to solve problems. I can solve political problems as well
As mechanical.
not myself, but I mean I can see how they can be solved. I can solve problems in almost any field if you like it. If I have the facts and know what the human relations are, I might solve that too. But this is part of being creative. And in other words, you're a problem solver. That's what it amounts to.
Well, have you been able to analyze more of what it is that makes you different? In other words, how do you think differently from most other people?
Well, most other people are not problem solvers. That's what it amounts to. I mean, well, let me illustrate it. When somebody states a problem, I don't care whether it's in engineering or something else again. I begin to think of solutions for the problem. And generally, if I was asked to, I could find half a dozen or a dozen solutions for it. But I have one other characteristic that some of the people who are maybe creative too, I think do not have to that same degree. I have a critical sense as to which problems are practical and which problems are not. And I don't mean to say that all the problems I can solve are completely practical, but I mean you throw out the ones which are obviously impractical, you see. And a lot of people, I've run some competitive tests with other people who are good problem solvers or good creative too. And generally, I find myself in thinking of this or that kind of a solution, I find myself throwing out the ones that are so obviously impractical that you might just well forget them. But a lot of the people put these things in. And I don't know. I don't know what the difference is there.
For some reason, your illustration makes me think of Washington, D.C. and the people there, where they have a tendency, it seems, to come up with solutions to problems which are very impractical at times, and they don't reject them. They put them into effect.
Yeah, that's right. Well, of course, when you, I found that in competing with other people, I put down a shorter list than most of the people, but the list wouldn't contain any of the wild ideas that they had, you see. And I don't know what the reason for that is, except that I tend to think of whether the thing is completely impractical or not. I'm willing to give it the benefit of the doubt, but when it gets too wild, I throw it out.
Well, why do you think that you became a creative person? Do you think it's something that
I think you're born with it.
Born with?
Well, let me put it in a different way. I suspect that as babies or as small children, there are a lot more creative people than grow up. Yeah. And I think that the process of education is part of the problem. That is, it beats the creativeness out of a lot of people. They are intimidated. If they're creative, they tend to be oddballs, and they try to avoid that. And in the process, they lose their creativeness. I don't know. This is just a guess, but I think that that's what happened. I think that was what Willis Carrier meant when he told my parents about me, that not to lose it in the process of education.
Well, when did you decide that you wanted to become an engineer, and why did you decide?
Well, of course, I remember very well the visit of Willis Carrier that day.
How old were you at the time?
Oh, about 7 or 8, and he was down to promote or display some of his equipment at I think, international hygiene conference, if I'm not mistaken. And we went down. They had a building where they had some things on display of different sorts, and he had a spray type humidifier that had opposing sprays, some with airflow and some against airflow, and an eliminator to eliminate the spray from prevent it from coming through into the fan. Then he had the fan on the discharge, and he had some ribbons to show the air fluttering up at the end of it. Then he had a door, a sealed door that you could close and had gaskets around it so that you could seal it. And I don't remember whether he had lights inside it, but the lights shone in it so you could see the sprays going in there. And I was very much impressed with that. I thought that this is something that was practical, that he'd done himself. And so I was a great admirer of Willis Carrier, and always was. Later I learned that he had some flaws, and he always was from the standpoint of his ability to think creatively, he was always greatly admired by me. And many of the things that I had been working on were mechanical in character. When I was in high school, I spent a couple of years in Nashville, Tennessee, and I got started late in grade school, but I skipped 2 grades when I was in Nashville. So I came back to Washington and went to high school. Then I was only just 13 when I went to high school. Graduated when I was 16. And during at least 2 of the last years, some friends of mine and I formed a radio club. And that was at a time when the Fleming tube, that is the vacuum tube, was just developed. And initially we used crystal silicon or galena or something of that sort, and a hair going down to it to be able to receive messages. And there was a time station over at Arlington, across the river from Washington. And we hooked up our radios to that, and we wound our own coils and practically made the whole radio. And we could hear the station. Of course, it was sending code, and I never did learn to signal in code. Never did achieve that. That was not the kind of oddball characteristics that I couldn't do that. And but we were very much interested in radio at that time, and my friends some of them went to MIT. My mother and father, my father had graduated from Cornell, and my aunt and uncle had gone to Cornell. My mother was a special student at Cornell. And then my father got his doctorate out at Stanford. He was the first doctoral candidate. But it seemed very logical to go on to take mechanical engineering. I knew the dean of engineering there, and the former dean who acted as president for a year or so.
This is at Cornell?
At Cornell. And admired them. And so when it came to choosing between mechanical and electrical, I decided that mechanical was the right thing to do, and I was interested in the meantime in joining Carrier Corporation, Carrier Engineering Corporation then. So does that answer your question?
Yeah, and I can see why you would have
sure.
done this, especially with your association with Carrier prior to that time.
Right.
Well, when you began working at Carrier, did you foresee that air conditioning would become the large industry that it has become?
Well, yes, I could see it because, of course, at that time, all of the jobs were special. But it was evident that there was air conditioning to be done all over, and of course, there was refrigeration was really part of the mix to some extent, and because it was necessary for dehumidifying, or nearly necessary, they did use some well water on some of the initial designs. For instance, I think the first air conditioning unit that Willis Carrier built used well water.
At Sackett-Williams frame plant?
Yeah.
Yes.
I think so, yeah. And they used quite a bit of well water. And, but really at the time that I joined it, they were trying to use more and more refrigeration, which in those days meant they used ammonia or CO2. Or very small plants, maybe SO2. But there were a lot of handicaps about that. And when I finished high school, I finished when I was 16. And I think a little immature, even at 16. And my parents felt that I needed a little time between the time I went to college and the time I finished high school. And so it was arranged that I worked for Carrier for a year between 1960 and 1970. And the first job that I was assigned to was we started, I guess, in June or July, in a tobacco curing job, a shade tobacco curing job in Connecticut. It was a very interesting project. And it was done in they had these hands of tobacco. Of course, the shade tobacco was the wrapper type for cigars.
So that was what type of tobacco?
Wrapper that went on the outside.
Like what did you call it?
Shade tobacco.
Shade?
Yes, it was. They grew it in shades. They had over the whole field. They had sort of like cheesecloth,
Oh.
and then down the sides as well. And the tobacco was very carefully picked, and they had long sticks with nails sticking up both ways on the side of it. The people that picked it would stick the stem on the nail, and they'd have 2 or 3 leaves on each stick. Then they would take it and put it in big sheds that had louvers on the side of it through which the air could pass for drying it, curing it finally. And the farmers had to adjust the louvers according to the weather outside, and a lot of it didn't work very well. And what they were trying to do was to substitute curing by air conditioning. And so we ran a whole series of tests. There were 3 of us. The other 2 were college students. And actually, I knew just about as much as they did. And we ran wet bulb tests, dry bulb tests, and adjusted the chambers in which the leaves were tested. But when the university started up again, we had done most of the work during the summer. When they started up again, they had to go back to the universities. So I was left all alone to finish the thing up. and I ran some of the tests on a 24-hour basis. I had to run tests to test measure the tests in every hour. And during the night, I'd set my alarm clock for the next hour and lie down on the tables that they had for sorting the tobacco, go to sleep. Interested in that. But at the beginning of the next year, after this project was finished, I went to Buffalo and worked directly under Willis Carrier. And Willis was a hard taskmaster, and he insisted that you do things right. And one of the things that he maintained, and I agree 100% with him, was that you should think in terms of fundamentals. In other words, you shouldn't think in terms of empirical type of things. You should go back to the fundamental laws of nature and then develop your ideas from those rather than from something intermediate between. And I think that because he could think in fundamentals was one of the reasons why he had great confidence in what the performance of his equipment would do. And later on, he brought some of the engineers in Carrier Corporation together to see to what extent they could think in fundamentals. And he asked them a series of questions which they could solve easily if they could think in terms of fundamentals, but they'd find difficult if you couldn't. And a lot of them flunked. But at any event, it was a great experience to work directly under him. And I would do some of the test work that he wanted to do. I remember working in a macaroni factory, running a test down at Jamestown. At the time that we were there, we worked in Buffalo, and but running a test on a power plant down in Jamestown. I think there was another one that we tested east of Buffalo, but all of it was very educational to me, and so that was the first experience that I had actually had in doing work, and I think I reasonably qualified to do the work that I was selected to do. Now, let's go on to the next issue.
Okay, you no doubt knew many early industry pioneers.
Yeah.
There's a lot of information on Wilkes Carrier.
Yeah.
There's little on others. Who of the early industry pioneers did you know well enough to tell us something about them besides Wilkes Carrier?
Well, I knew quite a few of the carrier engineers, but very few of the other to the same degree.
Who are some of the people that stick out in your mind?
Well, A.E. Stacy.
What was his full name?
Alfred E. Stacy. I don't know what the middle name was. And A.C. Buensod was the man who supervised the tobacco work.
Well, talking about Stacy, for example,
yes.
what can you tell us about him?
Well, he was a very, very meticulous person, and very, very kind, personable sort of a person. He had some creative ability, but he didn't compare with Willis Carrier in respect to that. He did actually had some patents and did some design work. For instance, the atmospheric cabinet that was built for testing, humidity testing on different varieties, I think was his work. And I think he did some control work. Personally, he was a very, very pleasant person, very kind and approachable and very satisfactory. And I knew his wife as well, very well. And after I started with Carrier, after I finished college at 1924, I worked directly under Stacy for a couple of years, and largely running tests on different materials. And well, I did a lot of things, and a number of them were not under him, but I reported to him for the first 2 years at any rate. And he was a very, very pleasant person. Buensod was a rather different personality.
How was his name spelled?
A.C. Buensod, Alfred, I think it was. I've forgotten.
And his last name was spelled how?
Buensod, Buensod. And later on, incidentally, Buey and Stacy formed Buensod-Stacy Company. That, well, I guess it still operates. But was quite a factor in the air conditioning. That occurred, I think Buensod left. Well, Buensod's specialty was tobacco, cigars and cigarettes and so on. And during the period that I knew him, I worked for him in 16, and Carrier did a lot of business in the tobacco field, in the processing of tobacco, because it needed a certain humidity and temperature, so on. And it was largely handled by A.C. Buensod. And but when the Depression came along, there was not very much work in the tobacco industry. And I guess at that time he was separated from the company and started his own firm. And I judged, I didn't know much about the firm, but I judged that he was one of the prime, certainly one of the two prime movers in the firm. And the other was Stacy. And both of them were very able people. I think in the firm that they started, I don't know if they were the originators of it, but they were identified with the two conduit air conditioning systems. That is, one would be cooling, the other would be heated. And they installed a lot of those, and particularly in manufacturing plants, where they wanted to get accurate control of relative humidity as well as temperature. Well, does that give you enough on them?
Oh, yeah, that's enough on that. Who else?
J.I. Lyle, who was president of Carrier, or chief executive officer at any event. Maybe he was treasurer, but at any event, he was the CEO for all practical purposes, except when it came to technical matters, and then Willis Carrier was the head. J.I. Lyle grew up in Kentucky, and he was a Kentucky gentleman of the old style. He was a very fine salesperson, and as I say, he was an old style Kentucky gentleman, a very able person, and very polite. He had a very high regard for the family, and considered that the members of Carrier Corporation were part of his extended family. And he treated them that way. And when the Depression came along, and Carrier sank lower and lower in it because they didn't have any, they lost a lot of business. He found it very difficult to adjust to that situation. He didn't want to wouldn't fire anybody. And he didn't want to do some of the things that were obviously forced on anybody to do at that time. Willis Carrier was more realistic about it than Lyle. But eventually he was forced to do that and to take other compromises. but I don't mean to be derogatory. I mean this was part of his characteristic. He hated to fire anybody, and he's a good deal like our present president. He valued friendship, and I remember a number of times I attended parties at his house. He'd give a party on New Year's Day generally, and a beautiful party, a very, very fine party. And as I say, he was a very fine person and able, but he had some weaknesses. And the weaknesses were, in a sense, his strengths too.
What do you remember that he contributed anything as far as any type of outstanding advances in the industry or anything?
Oh yes, I'm sure that he did. His advances were not so much his own contribution, but the arrangements that he made and the sales that he helped to promote. One thing that was very interesting that occurred shortly before I came with the company after college was that Carrier decided, first they bought a small place or rented a place in Newark and prefabricated a good deal of the ductwork and some of the equipment that was necessary for their custom-made jobs. And this was done much better in a sheet metal shop than it would be done on the job, although they, of course, would send brakes and shears and things of that sort out to the job as well. But then they made a very momentous decision, and this was, I think, decided somewhere in the neighborhood of 1920. They decided that they were going to go into manufacturing. And one of the things that caused that is that Willis Carrier had been bothered for a long time about the weaknesses of refrigeration. The refrigeration had been the ammonia refrigeration, of course, was poisonous, and it had to be put through cooling coils, direct expansion cooling coils in water, and then the water had to be circulated. And the CO2 was highly inefficient. And so the combination of those two things meant that there really was no good refrigeration to go along with the air conditioning. You had well water, but the well water temperature in most places was too high. And so he began to think about the process of refrigeration, and he concluded that if he could design a machine that would work at a pressure below atmospheric pressure, even if the refrigerant was toxic, it would not get out into the space, and therefore it could be made acceptable to put this refrigerant machine in the various places where it was needed to provide cooling for air conditioning. And so, on that basis, he conceived of a refrigerating machine that would meet these demands. And what he was visualizing was the fluorinated, or originally the chlorinated hydrocarbons, such as, well, a good example of that would be carbon tetrachloride. That wasn't a good refrigerant, but there were other refrigerants that had much the same character of quality. And so he had to handle a large volume of gas at a low pressure difference. And so what he did was to go to Germany, where they made centrifugal compressors, and arranged to tie up with the German company. He designed the seal. Most of these compressors were for air. They adjusted the design to the refrigerant properties, which were different from air. Then Carrier designed a seal to go along with it to prevent the air from getting in, or the refrigerant from getting out, and then designed water-cooled or condenser, water-cooled condenser and the evaporator to go along with it. And he had a refrigerating machine. And this was done just about the beginning of the 20s. And then they purchased in Newark a factory, and started manufacturing. They of course made the ductwork and prefabricated material of that sort. They made, and they had purchased, continued to purchase casings and the standard material from Buffalo Forge, and I guess continued to do that. But at any event, they made some fabricated ductwork, and the primary reason that they shifted over was because of the centrifugal refrigerating machine. But at about the same time, a man by the name of Larry, I'll think of his name in a minute, got the patents on a machine to make crimpled fin aerofin, that is, along the fin around the tube. And you see, before that, the heating and the cooling tubes either were done with pipe coils or cast iron, great, enormous, heavy things.
I think the name you want is Sewell.
So Larry Sewell, that's right, Larry Sewell. That's funny too, because my the co-grandparents are named Sewell. Funny that I should have forgotten it. But
the spelling of Soule is S-O-U-L-E.
That's right. That's the same spelling. And so what? And you were asking about J.I. Lyle. That's Joel Irving Lyle, if you want the name. But everybody called him J.I. What he did was to negotiate with the fan companies and the heater companies to manufacture paraffin coils, heating coils primarily. And Carrier would manufacture those in the Newark factory. And this was quite a coup. And because they bought stock in the Paraffin Corporation. They owned it jointly. But Carrier had the license to manufacture it. We had the relationship with Sewell and with the Hungarian who had designed the manufacturing machine to make the surface.
Who did Sewell get the patents for the wound fin from?
He was a Hungarian, and I'll think of his name in a minute. A very common name in Hungary. If you think of a common name, that's probably right there. His name.
I don't know any Hungarian common names.
But at any event, this was an older man, but very smart. Very smart as a tool designer. And later on, he did a redesign of his fin tube and stretched the outside of it so as to cut down on the amount of corrugation that was necessary on the inside. It made a much better fin. I'll remember it in just a minute.
Okay.
I have a delayed memory.
Okay, keep on.
Yeah. And so at any event, that you see, that gave Carrier a big entree into the manufacturing with the centrifugal machine and the paraffin. Yeah. And later on, J.I. Lyle negotiated another thing. Logan Lewis was another man that I knew very well. And Logan had been doing some work with theaters, and he air conditioned a theater out in California. And previously, we had handled in the first place the cooling water temperature was about 50 degrees, and the idea was that you sprayed water into the air, and of course then the air temperature became 50 degrees too. But they didn't, at that time, they didn't like to handle 50-degree air temperature. And so they were troubled by that. And matter of fact, some of the jobs that were installed did use 50-degree air temperature coming out of the humidifier. And then they heated the air with a steam heat. Well, of course, that was obviously a very inefficient way to do it. They thought that they couldn't distribute air below about 60 or 65 degrees.
Why did they think that?
Well, because they hadn't been successful in doing it. All of the work that they'd done with distributing air. This was for comfort conditioning now. It was at higher temperatures, and they used these distribution from the ceiling cylinder. Incidentally, over at this new place, the place is very drafty. And I noticed that they've got ceiling ones too.
Talking about the Congress Center.
Yeah. Have you noticed that?
No, I haven't been over there.
Well, it is. It's very. I was up there at a place this morning, and I had to move away from this thing because it was too drafty, and that's inexcusable. But because we know better than that now. But that they dump the stuff right down there to low temperature.
So they made the same mistake that they were making 75 years ago.
Right. But they thought that they needed a higher temperature in order to get proper distribution. So what Logan Lewis did was to say, well, instead of, why don't we take some return air from the room, and we'll bypass the dehumidifier. Well, he got a patent on that, and
that is the so-called bypass.
That's the bypass method. He got a patent on it, and J.I. Lyle negotiated an agreement with all of the current air conditioning companies. I think it was in the late 20s, if I'm not mistaken, or under what was called an auditorium corporation or something of that sort. And
auditorium conditioning corporation.
Something of that sort, yeah. And the essence of the thing was that this actually wouldn't have been legal today, but the essence was that it was a sort of an agreement to control the business. In other words, they, for one thing, they charged a royalty on a seat basis, or this was done largely for auditoria or theaters and movie houses and so on. And they charged a fee for it, and then it was I think distributed to the various companies again, you see. But that gave them each a license under the auditorium patent, and it in a way it stabilized the industry. They didn't attempt to do any rank control or anything of that sort, but it recognized that there were certain. I think to some extent it served as a standardization program as well. It was operated exclusively by the companies in the business, and eventually the patent was thrown out. It was disqualified, but I think they continued the Auditorium Corporation for a while after that, if I'm not mistaken. But of course, without the patent, it didn't have quite the force that it had previously, because other companies then could come in and copy the bypass method. So those were some of the people. I knew Logan Lewis well, and I knew Mr. Smith, M.S. Smith. In fact, I rode in to work with him. I didn't have a car until about 1929, and I didn't feel I could afford it. But
what did M.S. Smith do?
He was the treasurer, a very tight treasurer. He was a very effective person as a treasurer. He did a good job. And then the other people I didn't know quite as well as those. Most of the other people who had formed the company in the first place were sales engineers. They had training from Willis Carrier on how to design equipment, how to design jobs, and take the air conditioning equipment that was available and make it run for the various jobs that were available. And let me see something of this. I'm sorry to be so slow about
Oh, no, that's fine. We got plenty of tape.
Heckle, Ed Heckle was one of them.
Is that H-E-C-L-E?
Yes. H-E-C-K-E-L.
H-E-C-K-E-L.
And Murphy, I think it was Ed Murphy. And Lyle had a younger brother who didn't come up nearly to his stature, but he performed. He was a sales engineer. And also, incidentally, he participated in working out the specifications for residential air conditioning at a later time. I think it was E.T. Lyle, if I'm not, no, E something or other Lyle, Ernest, I don't remember his middle initial. And there were a couple of others that I can't identify right now.
One name that I see come up in old literature, apparently, who apparently was quite a pioneer of his time, was Walter Fleischer.
Oh, yes, yes. Well, I knew Walter Fleischer fairly well. He was part of our competition, and a very able guy.
What did he have his own company, or?
Yes, he had his own company.
And he was what, I suppose, a consulting engineer.
Yes, I would guess so. But I think I'm not sure whether I think at a later time they manufactured as well, if I'm not mistaken.
What can you tell me about them?
Well, of course, being competition, he was the enemy, you know. And but he was a very smart individual, and he made a lot of contributions to the thing. I'm not sure that I can name specifically the contributions, but he was a big factor in the air conditioning field. And then, of course, there were, beside air conditioning, there were a whole lot of companies in the refrigeration business. There was York Refrigeration, and then there were in 1930, Carrier absorbed two other companies. One of them was Brunswick Rochelle. They manufactured both ammonia and CO2. The Rochelle company was out in Chicago, and the Brunswick company is in Brunswick, New Jersey. And I'll think of some other names of manufacturers, but there were several manufacturers. Some of them originally had made ammonia absorption machines as well as compressors, and a number of them have continued on. I think there are a few left that still manufacture reciprocating compressors and do a good job with it. At about the same time that Carrier took over these two companies, and we also had the Depression, of course, at that same time. DuPont came out with the Freon refrigerants, and prior to that, Carrier had used methylene chloride and what we call dichloroethylene, which was, well, we called it dialene, but it was dichloroethylene. There were two isomers of that, but they mixed fairly well. We used the dialene first, then we used the methylene chloride. And methylene chloride was christened as carrier number
one.
Carrying number one, that's right. And then as soon as I remember being invited to attend the presentation by DuPont of the refrigerant. Refrigerant 12 was the one they started with. And Mr. Carrier immediately saw that the same kind of a situation could work for a lower pressure refrigerant than that. And so he went to DuPont and said, can't you manufacture something that has a pressure below atmospheric at ordinary temperatures? So that was the origin of carrying number 2.
Which was refrigerant 11.
Refrigerant 11, right. And that was used for, well, it's still being used, I guess, in centrifugal machines. And was a very satisfactory refrigerant. Of course, it's relatively non-toxic. And I was, in the 1930s, I was invited to various demonstrations down at Deepwater Point, where in Delaware, or was it New Jersey? Delaware, I think. And there was a good deal of opposition to the refrigerants initially.
To the fluorocarbon.
The fluorocarbon refrigerants, and one of the things that they did at that time, there were very few, hardly anything in the way of safety standards, but the New York Fire Department did have some safety standards, and they set up a typical sized kitchen, about the same size, and put some burners on this, released the Freon 12 in the thing, and they presently got hydrofluoric and hydrochloric acid with a little phosphine mixed in with it. And they made a demonstration of this and said, sure, this is safe ordinarily, but when you burn it, it is a very toxic material. And it posed a real problem for DuPont. And they got busy and demonstrated a whole lot of different refrigerants using guinea pigs and rats and one thing and another, and they spent a lot of money in it. And that was during the 30s. And they finally won out for the things that ran in places where people are congregated. But they set up a lot of restrictions on it too.
I remember finding a report at one point in my travels. It happened to be in a library, but it was a report on the opposition to the Freon refrigerants.
That's right.
And it was done in New York City, and the engineer who was in charge of the opposition, you might say, was an engineer by the name of Edward T. Williams from New York City.
That's right.
And it was a very extensive, thick document trying to purport.
Yes, that's right. They didn't give up easily. But actually, as it settled down, the ammonia did continue to be used in industrial jobs. But the Freon refrigerant took over almost completely in jobs that were sensitive to individual people. And of course, the Freon refrigerants had the advantage that they could be used in direct expansion, whereas the ammonia system couldn't really. They did have some direct expansion chillers, but they were a hazardous thing, and under if you had anything like the present thing, they wouldn't be allowed at all.
Well, of the various other people that you knew then in the industry, whether it be air conditioning or refrigeration, is there anyone else that sticks out in your mind, of people that you knew, as far as,
Well, I
even
recall
the competitors even?
Yes, I recall. I recall Garland.
Milt Garden,
I think so.
who still is, he still is.
Yes.
In fact, he was at your luncheon today.
Yes, that's right. But he was from that period. I think if anything, he's a little older than I am. I'm 88, and I'll be 89 in August. And but he was a very fine person, and he was in one of the conventional refrigeration systems, and it still is.
Yeah, with Frick Company.
Yeah, Frick. That was one of the names I was thinking about. There's a couple of others that I forgot. And I knew some of the people. I knew some of the people in other companies, and in York. I've forgotten the head of the York company now. If you mentioned him, I'd remember his name, I'm sure. And actually, some of our competitors were taken over by Carrier in 1930. And for instance, there was another man from Kentucky. Oh, he was the one that started the F. Paul Anderson Award, and I can't remember his name now. You probably.
Maybe from Henry Vogt Machine Company.
No, he was from the York Heating and Ventilating Company.
The only person I can think of off the top of my head who was
he was head of the
Thomas Shipley.
No, Shipley was York Heating.
Yeah.
I mean York
Refrigeration.
Yes. Yeah. Shipley was one of the men I had in mind. I didn't know him well. In fact, I'm not sure that I ever met him. Well, I'll probably thinking of it, but he was the one that gave the money to start the F. Paul Anderson. See, F. Paul Anderson was the dean of engineering at Kentucky, and a whole lot of the early leaders came from Kentucky. They had apparently a very strong mechanical engineering program.
I see.
And many of them did. Many of the people that I knew were from Kentucky. I'd say a good share of the people that Willis Carrier organized originally, and when he was with Buffalo Forge, and many others besides that. How's your pick coming?
Yeah, we're getting down near the end of side one, but it's not quite there yet.
Okay. What is that, a 2-hour tape or something?
No, it's, in fact, I'm not sure how long it is. Yeah. It's theoretically 90 minutes, but it actually, on this tape speed, it's much longer.
Yeah. Well, I can tell you a lot more about some of our competition later on.
You're talking about many years later.
Yes, this would be probably mainly in the 1950s, which is still quite a ways back.
That's that's true.
But part of the reason that I can tell you more about it is that during that time,
speed takes longer. It's much
longer. Yeah. Well, I can tell you, I talk to you a lot more about our some of these competition on later.
You're talking about many years later.
Yeah, this would be probably mainly in the 1950s. Still, which is quite a way back. But the reason, part of the reason that I'm more bigger is about it, that during that time,
tape speed is much longer.
Yeah. Well, I can tell you a lot more about some of our competition later on.
You're talking about many years later.
Yes, this would be probably mainly in the 1950s, which is still quite a ways back.
That's
But part of the reason that I can tell you more about it is that during that time,
speed takes long. It's much longer.
Well, I can tell you, I talk to you a lot more about our some competition on later.
You're talking about many years later.
Yeah, this would be probably mainly in the 1950s. Still, which is quite a way back. But part of the reason that I'm more bigger is about it, that during that time,
tape speed is much longer.
Yeah. Well, I can tell you a lot more about some of our competition later on.
You're talking about many years later.
Yes, this would be probably mainly in the 1950s, which is still quite a ways back.
That's
But part of the reason that I can tell you more about it is that during that time,
speed takes long. It's much
longer. Well, I can tell you, I talk to you a lot more about our some of these competition on later.
You're talking about many years later.
Yeah, this would be probably mainly in the 1950s. Still, which is quite a way back. But part of the reason that I'm more bigger is about it, that during that time,
tape speed is much longer.
Yeah. Well, I can tell you a lot more about some of our competition later on.
You're talking about many years later.
Yes, this would be probably mainly in the 1950s, which is still quite a ways back.
That's
But part of the reason that I can tell you more about it is that during that time,
speed takes long. It's much
longer. Well, I can tell you, I talk to you a lot more about our some of these competition on later.
You're talking about many years later.
Yeah, this would be probably mainly in the 1950s. Still, which is quite a way back. But part of the reason that I'm more bigger is about it, that during that time,
tape speed is much longer.
Yeah. Well, I can tell you a lot more about some of our competition